Okay, so this is just a quick power example when we are dealing with factoring the sum or difference of two cubes. Some people call it SOAP problems. You need to know that these two names are synonymous. They sort of go together. SOAP is a mnemonic device that stands for same, opposite, always plus, and we use that along our way. And the sum and difference of two cubes. So I want you to picture in your head that soap is little cubes of soap, okay? We're at some beautiful shop, and they sell these specialty soaps, and they are little cubes of soap, all right? So when you see cubes, you're going to remember sum or difference of cubes, we're going to use soap. So what would that look like? Let's think of some perfect cubes. What's 2 cubed? What's 1 cubed? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and the list goes on, right? 4 cubed is 64. 5 cubes, we'll also see numbers like 125, 216, 343, and so on, okay? 512, 729, 1,000, I don't think I missed anybody, okay? You need to know that these numbers are perfect cubes. It's going to help you out. Now, sum or difference of them. So what if I had 343 x cubed plus 125? That is the sum addition of two cubes. So first thing we do is we put on our X-ray vision glasses. What is being cubed to make those? This has to be factored. It looks so little and simple. How could this possibly get factored? It's so innocent, right? What's being cubed to make 343? Well, it's 5, 6, 7. 7 and x. 7 cubed is 343. X cubed is x cubed. What's being cubed to make 125? 1, 2, 3, 4, 5. This is literally the sum of two perfect cubes. 7x is cubed, 5 is cubed. Factoring. What do we have to remember? We're going to get a binomial, means two terms, and we're going to get a trinomial. The trick, the cheap shortcut, is we take off these 3's, we put them in our pocket, save them for later to sprinkle our fairy dust. What's left behind when we took off the 3's? Just the 7x plus 5. Boom, our first factor is done. Now, our next factor. The way we get this one, now we're going to sprinkle our fairy dust. We're going to have 3 dots of dust and 3 dots of dust. What's 7x times 7x? 49 x squared. So that's what goes there. Next, what is our next dot of fairy dust? Goes here, 7x times 5. 7x times 5 is 35x. Don't put a sign in yet. That's what the soap is for the end. Then, after that, we have our next terms. Our next one is, sorry, I'm a different color pen. Let's see, maybe this is dark enough. 5 times 5, and that's 25. This is not like really like how we math. This is our cheap little shortcut. Now, soap, same, opposite, always plus. So we're going to use that same as the original problem, opposite, always plus. We just fill in our signs right now. So same is the same as the original. Opposite is going to be minus, and always plus. And that's it, you're finished. That is the end of factoring using soap to do a sum or difference of cubes, the end. So one more faster example. Let's say I had 27x to the third minus 216. Maybe I shouldn't do 216 because then they're both divisible by 3. It's a GCF problem. I'm not going to do that. Okay, 64, just so we can keep it simple. While you do, recognize that they're perfect cubes and write it as a sum or difference of cubes. What's being cubed? 3x. What's being cubed? 4. Now I recognize my ingredients. I do the factoring. I'll have a binomial. I'll have a trinomial. Take the 3's, you put them in your pocket. What's left? Your first factor, 3x minus 4. 3x times 3x, 9x squared. 3x times 4, 12x. 4 times 4, 16. Same, opposite, always plus. Done. Done. If you wanted to check, distribute 3x to everything, distribute -4 to everything, combine like terms, you should get back the original problem. The end.